Okay, so I've given you some times and from some velocities and velocity, derivative velocity, acceleration, and d is the distance. And so here we're supposed to figure out the object decelerates and velocities are given in the table. So here's the velocities in meters per seconds. Determine R6. So there's one, 2, 3, 4, 5, 6. And so if we're going to do R, that's the right side. So we're going to do the width of the interval is 2, and they're all 2. So we can just go 2 times the right side of the first one is 30, then 15, then 6, then 5, then 3, and 0. 15 and 5 is 20 plus 30 is 50. 659 times 2 is 118. And that would be velocity times time is velocities meters per second times time seconds cancel, and we just get meters. Okay, so the right 6 gives us a distance of 118. Left 3. So now we're going to split this up into 3 intervals. 1, 2, 3. We're going to do the left side. So the left side of the first one is 35. Then it's 15. And then there's 5. And these widths are each 4. So 15 and 35 is 50 plus 5, 55 times 4 is 55 times 4 is 220. And this would also be meters. Now let's see what M3 comes up with. So if we're going to do midpoints in 3 intervals, so we'll do the same 3 intervals, but the midpoints would be here. So we got at 30. At the midpoint on this, it's 6. Excuse me. And then 3. That's the heights at the midpoints times the width of the intervals are, again, 4. 0 to 4, 4 to 8, and 8 to 12. And so we got 36, 39 times 4, which is 40 times 4 is 160, 156. Okay, that's that one. Now 2. It says f of x is the derivative of capital F of x. And this is a graph of this. And so capital F of x would be, the change in it would be represented by the area. And it says do either right 4 or left 4 if f changing from 1 to 3. So we basically want the area under here. And I'm asking you to do it either a right 4 or a left 4. And there are 4 spaces here, each one a half wide. So we're going to have 0.5. And I'll just do the right 4 here. That would be height of 1, 2, 3, 4. Plus the right side of this one would be 1, 2, 3, 4, 5.5. And the right side of this one would be 6. So 10, 15.5 times a half is 7.75. There's no units given on here, so we can't give any units. Now, if I didn't, this is would have been right 4. If I'd done left 4, I would have had a height of 2, a height of 4, a height of, oh, did I miss one? Yes, I did miss one over here. Sorry. Right 4, I would have had 4, 5.5, 5.8, and 6. So I missed one. Boop. So 4 and 6 is 10, 5 and 5 is 10, so that's 20, and 0.5 and 8 is 1.3, so that's 21.3. 21.3 times that 0.5, so that would be 10.65. Okay, left 4. Okay, so now we're doing this side, so that's 2, and then it would be the first 3 of these, 4 and 5.5 and 5.8, each a half wide. So 2 and 4 is 6. These together are 10, 11.3, and 6 is 17.3 times a half, which would be 8.65. I believe, unless I did some mental arithmetic incorrectly. Okay. I find this a fun problem. It says f of t is the thickness of ice on a roof after t hours after midnight. So t of 2 means 2 a.m. t of 7 is 7 a.m. So the thickness is 4 inches at 7 a.m. At 9 it's 5 inches. At 2 a.m. it's half an inch. And this says from 2 to 3:30 a.m. the area is 0.75, so it increased from 2 to 3:30 by 3/4 of an inch, and 4 a.m. to 7 a.m. it increased by 1.5 inches. Get how to read these? So the first one says from 7 to 9, how much did it change? Well, at 7 it was 4 inches, at 9 it was 5 inches. Meaning this would be, and if you wanted to write this down, it would be capital F of t evaluated from 7 to 9. So you'd have f of 9 minus f of 7. So but it went from 4 to 5, so that's 1 inch more. 5 minus 4 is 1 inch increase in thickness of ice from 7 a.m. to 9 a.m. Okay, next one. F of 4. So this means we got to figure out how thick the ice was at 4. So at 7 a.m. it was 4 inches, and from 4 to 7 it went up by 1.5 inches. So that means if you go back that 1.5 inches back to 4 a.m., it had to be 1.5 inches less than 4, so it's 2.5. Now, to write it, I'd write 4 minus 1.5 is 2.5 inches thick at 4 a.m. Now we got to figure out what was it at 330. Well, from 2 to 330, you went up by 3/4 of an inch, and at 2 it was a ½ inch. So at 330, it must have been a ½ inch plus 3/4 of an inch is 1.25 inches. So 0.5 plus 0.75 is 1.25 inches at 3:30 a.m. This one. So this says, how much did it go up from 4 to 9? Well, at 4, we figured out it was 2.5 inches, and at 9, it's 5. So it increased 2.5 inches, divided by how much time it is between 4 and 9, which is 5 hours. So this is how many inches per hour it grew on average. So this comes out to be, if I divide that, it comes out 0.5 inches per hour average rate of increase. Okay? So it's just, do you understand this notation and what's going on? Okay, number 4. This one is a clever one. Let's see if you can understand. So we have an odd function. Key thing to remember on an odd function is that it has origin symmetry for like x cubed. So whatever it does on this side, it does up here, or in any odd function will have this symmetry. So for instance, if it says from 0 to 2, if the area here is +3, that means from -2 to 0, it's -3 because of the odd function symmetry. And if it says from -2 to 5 is 8, from -2 to 2, the total is -3 plus 3, 0. And if -2 to 5 is 8, then this must be 8. Because we'd have -3 plus 3 plus 8 from -2 to 5. Which means, since it's symmetric, from -5 to -2, it's -8. So, 0 to 5. 0 to 5, well, that's going to be 3 plus 5, 11. From 2 to -5. 2 to -5. Oh, that's backwards, so that's going to change the sign. That would be -8, but since we're doing this from 2 to -5, it'll be +8. And then from -5 to 5, since it's an odd function, that's got to be 0. Okay. So these, if it starts with a constant, you can ignore this, and it goes to something here, and we're taking the derivative of the antiderivative. It just gets this function with that put in. And to help you see it, if this was some sort of f of x, then this would be capital F of x evaluated from 2 to 5x squared. Actually, t, f of t, because this isn't t. And then we have to take the derivative, so of what this is. And so this would be capital F of 5x squared minus capital F of 2 And we got to take derivative of this with respect to x. And so the derivative of this would be little f with 5x squared put in it times the derivative of the inside, which is 10x. And then the derivative of constant is 0, so it would be this. So all you really do is put this in place of the t, and you get the square root of 5x squared quantity cubed plus 4 times the derivative of that, which is 10x. Okay, find these indefinite integral. So if you're going to integrate x to the minus 2, you add 1 to that, be minus 1. And you divide by that, so it becomes minus x to the minus 1. This, you integrate this, well, this is 2 to the 1/2 x to the 1/2, or square root of 2 if you wish. And so to integrate x to the 1/2, you add a 1 to it, and it becomes 3/2, and so you're going to take it times 2/3. So we're going to have plus 2 square root of 2 over 3, 2/3, x to the 3/2. So minus 2, and the integral of sine of x is negative cosine of x, and that's a simple x, plus c. You can leave it like this, or you can try to do some simplification. Like this might be minus 1 over x. Not much you can do here, plus 2 square roots of 2 over 3. You could say this is x times the square root of x. And not much you can do here, 2 cosine x plus c. You might like that a little better. It's not a whole lot better. This one, easiest to put this under each one of them. So we'd have the integral of, if we put x squared under x to the half, we subtract 2 from a half, and we get 5x to the negative 3/2 minus, and this would be x, because cubed over squared is just x, dx. So this would be, increase that by 1 or 2/2, that'd be minus 1/2, so it would be divided by a minus a half would be times negative 2 times 5, x to the negative 1/2 minus 1/2 x squared plus c, or minus 10 over the square root of x minus x squared over 2 plus c. Something like that. This one, we cannot do that. And this has an x, which happens to be the derivative of the whole denominator, so we're going to let u equal x squared minus 1. du would be 2x dx. It has an x that'll cancel that x because we're going to divide by 2x on both sides. So we know what to replace dx with, and so we're going to have the integral of 3x over u times du over 2x, and the x's cancel, so we get 3/2 the integral of 1 over u du, which is 3/2 ln of absolute value of u plus c. But we should go back to x, so it's going to be 3/2 ln absolute value of x squared minus 1 plus c. And now we're going to do this one. So this one doesn't have an x, and the derivative of this, if we let u be the whole denominator, would not help. So now we're going to have to make this one looks, it's kind of like the x squared plus 1, which is inverse tangent. So we're going to try to make it be something squared plus 1. It's already a 1, so we don't have to worry much about that. The 5 can come out. So, but we got to make this be something squared. So I'm going to call this, see, 4x squared is like 2x quantity squared. And so I'm going to let u be 2x. du is going to equal to dx. And so I'm going to have 5 integral 1 over 2x is my u, so u squared plus 1 du, because dx is equal to du. And this looks like the inverse tangent, so this becomes 5 tangent inverse of u plus c, and then that'll change to back to x's will be 5 tangent inverse of 2x, because that's what u was, plus c. Okay. And the final page. So here we go. We have an absolute value of x squared minus 4. So what does that look like? X squared minus 4 is going to be down 4. Over 1 it's going to come up 1, and over 2 it's going to be 0, because 2 squared minus 4 is 0. And same here, minus 2. And this is down 4. And so we're doing the absolute value from 0 to 5. So we need to turn this part positive. So to make this area positive, we're going to have to go like this, which is going to be minus x squared plus 4. So we're going to integrate from 0 to 2, 4 minus x squared dx, to get this area to be positive. And then we're going to add to it the integral from 2 to 5 of the regular equation, x squared minus 4 dx. So integral of 4 is 4x, and this is going to be minus 1/3 x to the third, evaluated from 0 to 2, plus, over here we're going to have 1/3 x to the third. Oops, this was minus, yeah, that's right, minus 4x. And this one we're going to evaluate from 2 to 5. So if we put 2 in this, we're going to get 8 minus 8/3 minus, put 0 in here, we get 0, plus, here we're going to put 5 in, and we're going to get 1/25. And then we're going to put in 5 in there, minus 20. And then we're going to subtract. We're going to put 2 into this, and we're going to get 8/3 minus 8. So we got, combining like terms here, so we got 8, and minus a minus 8 is another 8, so that's 16. 0's gone, and then we got minus 8/3, minus 8/3, that's minus 16/3, and plus 125/3 and minus 20. So here we have minus 4, and then we have 16 from 125 is 109 thirds, and that would be plus 109 over 3. So 3 would go into 10 3 times, 3, that would leave 1, and 3 goes into 19 6 times, that would be 18, so that leaves with 1/3. So we got minus 4 plus 36 1/3, which is 32 1/3. Okay. B. Okay, well, looks like the derivative of x to the third is going to be an x squared, so I'm going to let u be 8 minus x to the third. 8 minus x to the third, so du would be minus 3x squared dx, so dx can be replaced with du over minus 3x squared. So this integral would change from, be new limits because I'm changing to u. Now, u was 1, or x was 1. 1 cubed is 1, from 8 is 7. And 2 to the third is 8. 8 minus 8 is 0. Of, we have a 4x squared. We have e to the u over times du over minus 3x squared. The x squareds cancel. Take the 4 over negative 3 out. Integral 7 to 0, so it's backwards. I could change the sign and switch those, but don't need to. Integral of e to the u du. Oh, I've changed u, so I changed these, yes. So we're okay here. So then I can just integrate this, and it's going to be integral of e to the u du is just e to the u. So I'm going to have 4 over negative 3 e to the u evaluated from 7 to 0. So if I put 0 in, I get minus 4 thirds. E to the 0 is 1, so I'd get minus 4 thirds minus 4 thirds times e to the 7th. And so that actually turns into be plus. And I can factor out the 4 thirds or not, but close enough. Okay, C. Well, the derivative of sine of theta plus 1 would be cosine theta, so I think that's going to cancel, so I'm going to let u equal sine of theta plus 1. Du would be cosine theta d theta, and so d theta, this should be theta here. My bad, mistake in my test. The angle is theta, so that should need to be theta, d theta. D theta can be replaced with du over cosine theta. And so we're going to have integral. Now the limits are changing. If I put 0 in, sine of 0 is 0 plus 1 is 1. And if I go to pi over 2, sine of pi over 2 is 1 plus 1 is 2. I have cosine of theta, I haven't changed that one, over square root of u, and d theta is equal to du over cosine theta. So that's u to the negative 1/2. So to integrate it, I'd increase this by 1, which would be 1/2, and divide by 1/2, which would be multiplied by 2. So it's 2 square root of u to the 1/2. Evaluated from 1 to 2, since I've changed my limits here. So I'm going to get 2 square roots of 2. minus 2 square root of 1, which is just 1, so minus 2. Okay, well, I've got stuff in the denominator here that kind of looks like the derivative of this, because I'll only double it. If I took a 2 out, it'd be x squared plus 2. That's an x squared plus 2. So if I let u be ln of x squared plus 2, then du would be the derivative of this, which is 1 over x squared plus 2 times the derivative of the inside, which would be 2x dx. Now, then this looks like the reciprocal of this, except there's some 2 stuff going on in here. But I think it'll work out here. So I'm letting u be ln of this. So if I put in 0, I get ln 2. And if I put 2 in there, I get ln 8. No, ln 6. 2 squared is 4 plus 2 is 6. ln 6. And I'm going to have x, and then a denominator, I'm going to factor out a 2. I'm going to have an x squared plus 2. In the numerator, I let all of that be u. And dx is du times x squared plus 2 divided by 2x. Multiply this by both sides and divide by 2x. And this x cancels that x, and this cancels that. And I have a 2 times a 2, which is a fourth, because they're both in the denominator. The integral of u du is 1/2 u squared, evaluated from ln 2 to ln 6. So 1/4 times 1/2 is 1/8. And then ln 6 in here is going to be ln 6 squared minus ln 2. 2 squared. Good enough. Okay, we have a differential equation, and it's equal to this. So if we integrate both sides with respect to t, the integral we'll move this dt over here. So the integral of dy is y equals, the integral of this would be 3 divided by 3, 4/3 t to the third. The integral of 2t would be plus t squared plus a constant. And it says when t is 0, we're supposed to get 5. So 4/3 times 0 cubed plus 0 squared plus something is supposed to be 5. Well, all this will be 0, so c has to be 5, and so y would be 4/3 t cubed plus t squared plus 5. And finally, if we integrate both, we have y and y here. When you have a constant, the derivative is equal to constant times the original. This integrates to y equals a constant e to the k, which is 1.4 t if t is our variable. So, and if we put in 0 for up here, all this goes to 0. We can make that x if you want. It doesn't matter, x or t. If you put in 0 in, you get e to the 0, which is 1 times something. It's supposed to be 5, so this would have to be 5. And there's the equation. And that's